Hello students, welcome to mathematics class. Students, this is part 4 of the chapter basic geometrical ideas. In this part 4, we will be learning curves and polygons. So coming to the topic curves. Students, what is curve is the first question comes into our mind. So to know what is curve, I will make you to recollect jotting that we do or doodle we say. Normally you take a paper when you are small child might have done some sort of a doodling or scribbling with pen or a pencil like this. This could be a curve. Understood? How you could do this? You can do them drawings sometimes without lifting pencil and sometimes by lifting the pencil too. This is done without lifting the pencil, and this could be another one wherein which without lifting pencil you might have done. This is another one. But sometimes to draw this fourth one, you might have lifted the pencil. See, I am going to show you few of the curves here. This 1 to 5, and I am going to show you two more, 6 and 7. All these are drawings made either by lifting the pencil or without lifting the pencil or a pen on a paper. All these could be examples for curves. So, normally you might have understood curve in general means not straight, but mathematically even straight is also a curve. Not only not straights all these, this straight is also called as curve. Remember that first. Here in this fourth figure I have shown you straight. Observe that curves in this one, that is in third, and in this seventh one, do you find any difference between rest of them with this third one and the seventh one? This seventh one looks like 8, na? Correct? This third one is somewhat, you could observe that here curve is crossing itself, whereas here it is not crossing, whereas here it is not crossing, whereas here it is not crossing, in this fourth one also not crossing, but it is a straight, and in sixth one also it is not crossing, just meeting, but here it is crossing. Here in this seventh one also it is crossing. Now I am taking you to next important. The pictures that are results of your doodling are called curves. This is the definition, or I say instead of definition, the meaning of a curve, which you can note down. The pictures that are results of your doodling are called curves. This is an important one what you have to understand. And next, I am going to give you two more. Consider these, one, and second this. Do you find any difference between them? What is the difference between them? What is the difference between these two? If you start thinking quickly in your mind, something comes into mind that stating, sir, first one is not meeting, second one is meeting. Now, what do you mean by meeting, children? What do you mean by that meeting? What is meeting the other? Now, you will say, sir, in the first one, ends are not meeting, but whereas in the second one, ends are meeting. Now, tell me, how could you say in this ends are not meeting, in this ends are meeting? Where is the ends in the second one? Do you have any ends in the second one? Which are the ends in the second one? But whereas in this case, you can say this is end 1 and this is end 2. But in the second figure, you don't find any such ends, right? There the definition of two important curves will come. Now, curves can be straights, you know that, and generally in curves there are two types of curves. One, the first one is open curve and the second one is closed curve. These are the two types. Okay, children? So, what is the definition of an open curve and what is the definition of a closed curve? That we will see after you doing some sort of observation. Now, I am asking you to go back. It is there on the textbook. Can you identify which are the closed curves and which are the open curves in the previous examples what I gave? Here, I gave you in this one, you know, here this is a straight, it is open curve and it is not meeting as you feel like, but in the definition wise or in the mathematical wise, there are ends which you can observe, visibly can see. So, it is open curve. In the first one, yes, there are ends which you can identify them. So, open curve. But now tell me in the second one, is it open curve? Do you find any ends? No. So, it is closed. It's a closed curve. Whereas, can I talk about this third one? I said this and this, though they are curves, since they are crossing a curve where it is crossing itself, these two are called not simple, very important, not simple curves, they are non-simple curves. Okay, they are not simple curves. We say not simple curves or non-simple curves. Okay, but whereas simple curves, which are the simple curves? First one is a simple curve, second one is a simple curve, fourth one is a simple curve, fifth one is a simple curve, even sixth one is also a simple curve. Why? Because here it is not crossing, like it is not crossing. It is not crossing like this. It is also simple curve, but it is closed. Why it is closed? Because we cannot identify that which is end point and which is starting point, or ends we cannot identify. Now students, the first, second, fifth, sixth and fourth, they are simple curves. Now what is the definition of a simple curve? Simple curve is a curve which will not cross itself. Okay, a curve should not cross itself. So now coming to the very important, this I have already shown you. Three important points what you have learned, you can note down. You can pass the screen and note down this. Okay. Students, hope you have already noted down. If a curve does not cross itself, then it is called a simple curve. In a curve, if you can identify the ends, that is endpoints, then it is called an open curve. In a curve, if you cannot identify the endpoints, then it is called closed curve. Okay. Now, I want you visualizing tennis court. Have you ever seen tennis court? I hope you all have at least watched in television, TV, a tennis game, or you might have played tennis. If you could observe a tennis court, in the tennis court, a court line is, we say, normally the boundary. In general language, we call boundary. Normally here there will be a net. We call this ends as a court line. This court line will divide the land into three parts. What are the three parts you know? First, when you are playing, suppose if a player is playing tennis, a ball hits ground, we say inside the court. That is considered. But if ball hits out of that court line, it is called exterior. Outside the court is called foul. But suppose if the ball hits on the court line, exact on the court line, outside, you know, exterior, you know, inside, interior, inside, exterior, outside. If it is hitting on the line also, it will be considered as in, accepted, not a foul. It is considered as a right ball. Remember children, here this court line is dividing this land into three parts: inside, outside, on the line. That is interior, exterior, on the line. You cannot enter inside without crossing the line. You know that. Similarly, you might have got your compound wall constructed for your house. A compound wall separates your house from the outside road or from the neighbor houses, right? So, here we are going to talk about inside of the compound, on the boundary of the compound, and outside the compound, with the names as a position in a figure. Okay. So we will consider that positions of a figure. That what are the positions in a figure? In a closed curve, there are three parts. Okay, children. In a closed curve, there are three parts. First part is interior of the curve, that closed curve, which we normally call inside. Second, boundary of the curve, which we say normally on the curve. Third, exterior of the curve, which we generally call it as outside of the curve. For example, in this figure, you could see 3 points. Point A, it is interior. Point C, it is an exterior. And point B, which is on the boundary. So, interior, exterior and boundary, if once you know, I will now introduce a word called region. Region. Remember children, the interior of a curve along with its boundary is called the region. Okay, very important. You can pass the screen and note down the definition of region. The interior of a curve along with its boundary is called region. Children, remember the paper on which you are writing, it is a rectangular region, not a rectangle. Why? Because that paper includes the interior portion along with its boundary. So, the place where you are writing that paper, top page of that paper is a region, rectangular region we say. Okay. Then now coming to the new terminology called polygons. What do you mean by polygons? Let us understand. I want you to observe few of the figures that I am going to give you. I am giving you 5 figures. First one, second one, third one, fourth one and fifth one. Could you identify any differences amongst them? Since it is a live, not a live class, I cannot hear you children. Otherwise, if we are physically sitting in a class and I am teaching you, then certainly I would be accepting your all the answers and seeing how you think. But I am helpless. I have to presume that you are talking like this. Okay. Anyway, with that presumption, let me start. What can you say about this? Are these closed curves? You all must say, yes sir, they are all closed curves. Why they are all closed curves? Sir, because I cannot say which is starting point and which is ending point among them. So, all are closed curves. Then you are all right. Children, here you could observe first, second, third and fourth. They are different from fifth one. Could you say that? Do you feel that? Yes. Why? Why do you feel like that? In fifth one, there is a different shape than in this first, second, third and fourth. What is the different shape? It has got some curve shape along with straights, isn't it? Whereas in this first, second, third, fourth, there are only straights. Could you see that? Yes, here I have all being straights AB, BC, CD, DE and AE or EA. There are line segments, am I right? Because there are endpoints, they are all made up of line segments, right? Yes. Whereas in the case of this, P, Q, R. Do you know the shape of this PQR? Yes, it is a triangle. Whereas in the case of third one, how many points do you require to show? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points you require, right? But whereas here, I can say this with only 4 points or 4 letters, because there are 4 corners. L, O, O, K. Look. What is the shape of this look? Do you know? It is a parallelogram. You have learnt. So PQR is a triangle. Look, LOOK. Look is a parallelogram. This ABCDE is a 5-sided. I'm sorry, I should not say sided because I didn't tell you what is side, correct? Anyways, children, here I will tell you the difference and I will stop this session. Next session of mine, I will start with the name of them. Okay. Here, the difference between 1, 2, 3, 4 and the fifth one. Fifth one is a closed curve made up of straights and some non-straight, that is curve. But whereas first, second, third and fourth, they are closed curves made up of line segments, correct? Being some with maybe number 1, 2, 3, 4, 5. How many line segments do you require? That we will see in next class. So this 4 are made up of line segments. These are curves made up of line segments, and whereas fifth one is a closed curve, but not just made up of only with line segments. It is also made up of along with the some sort of a curve shape. Now children, remember, this 1 to 4 are called polygons. These are polygons, remember, okay? Whereas what can you see? Are they closed? How does each one of them differ from the other? 1, 2, 3, 4 are special because they are made up of line segments only. They made up entirely of line segments. They are called polygons. Now you can note down the definition of a polygon. A figure is a polygon if it is a simple closed figure made up entirely of line segments. Remember children, this simple is also very important word. They should not be non-simple. They should be simple. Understood? You may get, sir, I have 1, 2, 3, 4. I made with only line segments, sir. Is this is a polygon? You may ask me. You say, no, this is not. Understood? Because it is crossing itself now. See, I will draw once again. First line segment, next, third, fourth. Without lifting, I have drawn with the line segments, but it is crossing itself. That's why it is not a curve. Sorry, it is not a simple curve. So if it is not a simple curve, it cannot be polygon. Correct now? So you write down the definition of a polygon. A figure is a polygon if it is a simple closed figure made up entirely of line segments, or in a simple words I will tell you of my definition, polygon is a simple closed figure made by only line segments. This is my simple definition. Okay, once again I will repeat. Okay, I don't want to use the bookish definition. I want to have a simple definition. Polygon is a simple closed curve made up of only line segments. So this is my definition, my way of telling the polygon. Okay, so choice is yours. Either you can take the bookish way of defining or the simple way of defining. So with this I'll wind up this session. Take care of yourself, be healthy and be happy. Jai Hind. Thank you.